All right, so let's take a look at this. Yes, I am. We'll see if it works. Here's the problem. Two jets leave San Francisco at 8 a.m., one flying south to LA at speed 40 kilometers per hour greater than the other, which is traveling north to Sacramento. So based on that first questions alone, I know it's going in and out, but that's fine. Listen carefully. Based on that first sentence, you know we have two objects, right? Yes. One going to the north, one going to the south. Which object is traveling faster?
The one going south.
The one going south?
North.
Wait, which way?
Which way? Good question. You know where Sacramento is?
Yeah.
Is it up or down? That's north.
Oh.
And down is south. You know how we say up north and down south? You don't say up south and down north, do you? It sounds weird when you say that, right? But you say up north and down south. That's how it is. So, yes, Ruben. Okay. All right, so we know at least that two jets here leaves San Francisco at exactly 8 a.m. And notice that at 10 a.m., the planes are exactly 2,480 kilometers apart. Find their speeds. I'm going to repeat that question again. Find their speeds. Right? Okay. I'm going to go ahead and switch over a little bit here. If I'm asking you to find their speeds, at least that will give you an idea on, there it is, what it is that you need to define. But before we even start that, I really hope that you can actually start making a diagram of this problem. First of all, think of this. Here's San Francisco right there. And we have a jet going to Sacramento, right? So I'm just going to draw an arrow pointing north to indicate that this jet is going to Sacramento. Okay, any questions so far on what I'm drawing? Okay. Now, there's another jet going south to LA. And notice, I hope this is not a coincidence, but notice I do have a longer arrow going south than the north. Why?
San Francisco's closer to South Sacramento.
Actually, they're leaving at the same airport, San Francisco airport. But why is this one longer and this one's shorter?
Because the one going LA is faster.
Yeah, good. So what does it mean? What does it mean in terms of speed? If you're going fast, that means what? You cover more distance or less distance? More. So it makes sense, right? That's why I have this here to represent that the distance covered by this jet is actually more than the one going to the north because it's going faster. How much faster again? 40. Okay, so can I say this? That this one is going 40 kilometers per hour faster. So I'm taking notes as I read the problem, and I'm actually using a diagram to show what's going on. So the one going south is going 40 kilometers faster than the north. And is there any other information about the problem I should know about? Yes? They're what? What else from the problem that you can actually get and write down?
They're 2,000
Oh.
something kilometers apart.
Very good. Apart, right? So that means the plane from here to here is exactly 2,480 kilometers in distance, right? If you had to take a measuring tape, I know which you can, and measure from one end of the plane to the other end of the plane, they are exactly 2,480 kilometers apart. This is all given from the problem, right? I'm not making this stuff up. What else did the problem tell you?
It was at 10
Huh? Oh, what time? What does it say about the time in there? You see how important it is for you to pay attention to every single word in the problem? Yes?
They leave at 8 a.m. Both leave at 8 a.m. and both at 10 a.m.
So that means how many hours later?
2.
Exactly 2 hours later. So 2 hours later, they are 2,480 kilometers apart. Does that make sense on the notes that I just put up here for you? Does this represent the entire problem?
No. Yes.
Everything that's from the problem that I put in here? Yes. Okay, very good. So give a scenario. I'm going to go ahead and set up two things for you. I'm going to call the jet going north, I'm going to call that the northern jet. And the one that going south, LA, I'm going to call that the southern jet. Just to, to differentiate the two. At least I know if I call it northern, it's going up north. It's southern, it's going south. Okay, we know that the southern jet is going faster. Is that true?
Yeah.
By 40 kilometers per hour?
Yeah.
So let's pretend. Notice, let's pretend. Do we know the speed of either jet yet?
No.
No. So let's pretend I call this, hey, let's say if the jet going south is going at 300 kilometers per hour, I just make it up. Remember, this is like a random guess. What if this jet is going at 300 kilometers per hour? Then how fast do you think the northern jet is going?
340.
340? Think. 340 or 260? Which one is going faster? Which one's the south? If the south's going faster, would it be reasonable to say 340 for the north? No. So once again, what am I trying to teach you today? Common sense. You clearly understand that the south is going faster, then how could you give me an answer that is even faster than the south, right? So what should I put here? If the southern jet is going at 300 kilometers per hour, 260 kilometers per hour, right? Is there any problem with this? No. Okay. Now, every time we have to deal with driving or going at speed of this or distance of that, would it be fair to say that we know we're going to be using this formula? Distance equal rate times time. Please remember this by heart. Distance is always equals to how fast you're going times how long you spent going. Does it make sense? How fast you're going times the time. So look at this. If we know how fast the northern jet is going, this is like a pretending, right? I pretend to know this is 260. And it's going for how long? Do we know the time in there?
2 hours.
2 hours. So if it's going for 2 hours at 260 kilometers per hour, how far did it travel? 520. So 520 what? How do you measure distance? Kilometers. Good. So this one, after 2 hours, it will cover 520 kilometers. What about the southern jet?
600.
Very good. Times it by 2 hours, you will also have 600 kilometers, right? But look at this. I know that the distance apart of these two have to equal to 2,480, right? If I try to guess and add these two together, it only adds up to 1,120 kilometers. Is that the answer I'm looking for? No. So you know that the speed of these two have to be slower or faster? Has to be faster. 1,120 kilometers, right? So let's just do one more guess. Take a guess. What do you think?
500.
800. Good. So let's say that the southern jet now going at 800 kilometers per hour. Yes, please. Say I'm busy. Times it by 2. How far did it go? If it's going at 800 kilometers per hour, 1,600 kilometers, right? Okay. Maybe they know I'm busy, that's why. Okay. Next one. Then, if the southern jet is going 800 kilometers per hour, then how fast is the northern jet? 760. If it's going 760 kilometers per hour, after 2 hours, how far did it go?
1,520.
Very good. And if I add these two, what is my distance apart? 3,120. Is that more than what I'm looking for? So you know at least that your speed of the two jet has to be in between 300 and 800 kilometers per hour. Does it make sense? For the southern jet? Okay, so at least I have an idea of what I'm looking for. Why am I doing this to you? Well, because I want you to see what your answers will fall into, instead of just like hoping to solve something that you don't understand what's going on. Okay, now when we see this, let's start with the solving part. Are we ready? Okay, here we go. So I'm going to use this diagram one more time, and let's take a look. The question asks, what are the speeds of the two jets, right? Since this question asks you to find a speed, how do we start the problem? What should we define? Variable to define what? The plane what? Speed. Very good. So let's declare this. Can I use N for northern and S for southern? Very good. So if I'm going to use N, how do I say, what is N? What do I write? Speed of the northern, right? And what about the S? Speed of the southern, okay. Okay. immediately if you see a pattern, every time I declare the variable, one variable, two, I will definitely going to be using them right away. If these two represent the speed, I want to come up with an equation to represent speed. Is there anything from the problem itself that has to do anything with speed? Look at what I wrote down as notes. Is there anything here that has to do with speed?
Yeah.
Yes?
It's going 40.
Oh, so this is the one we talked about, right? Which one's going faster? Okay, so let's go back to this. If we know the southern jet is going faster than the north, how can we tie this information in? The 40 here and an S. How do we tie that in to write our first equation, Jose?
S plus 40.
So you're telling me that the fastest jet, add 40 to it more.
N minus multiply.
And it's a slower jet. So you're telling me that the slower jet should take,
S minus 40.
S minus 40 equals to what?
N.
To N. So look, let's just check to verify if it's true. The fastest jet right here, take away 40, will give me the speed of the slower jet. Does it make sense? Yes or no?
Yeah, dude.
Can I write like that? Okay, then it makes sense, right? Perfect. Then we got our first equation. And notice, if I compare the unit, this has to do with speed, kilometers per hour, and kilometers per hour. Everything has to match. All right, moving on. We got the speed cover. I cross it out. I'm done using it. All I have to do now is go back to my information. What else do I have left over to use? I have hours, and I have the distance of the tube, right? But we also know that we have to use this variable again. Is that true? N and S. N represents the speed of the northern. S represents the speed of the southern. Let's take a look right here. If we are going to be using our variable to represent the speed, according to our formula right here, speed times times will give us what?
The rate.
Speed times time. Rate is speed, by the way.
Oh.
Rate or speed times time will give us what? Distance. So if we know that the speed of the northern represent using N, and then we have time of 2 hours, if we take the speed of the northern jet times it by 2 hours, what will we get back? I know. What does 2N represent then?
Twice the speed.
Wait, think. Distance of what?
The northern.
The northern what? Northern jet. So that does it mean 2 times N here will give you the distance of the northern jet? Is that true? Because I just basically follow the rule. Times the rate, or which is the speed, will give us the distance, right? So there it is. I got it. So what do you think I should represent for the southern jet? S times what? Very good. 2 times S, right? Because the speed of the southern. So 2 times S will give you the distance of the southern, right? Now look, if I have the distance of the northern, which is right here, and the distance of the southern, what can I do with the two distances here? Because notice I already used up the 2 hours, right? What can I use the two distances here to make it match up to here? What can I do? What can I do? I add them up. Very good. So go back to your equation here. What can I write? Yes? 2S plus 2N. There it is. The distance the southern jet travel plus the distance the northern jet travel should add up to 2,480, right? And there we have it. We have our two equations. What do you think we should do now? Do we have to line them up? Even before that, what should we decide? Yes? Good. Substitution or elimination. Which one's better this time? Substitution. But look, isn't N already solved for? N is basically this, right? So that means every time we see an N, we can replace N with S minus 40. So technically, can we just take this whole thing and substitute it into N? So it's better if we use substitution. You see it? So look, so let's substitute it. I have 2S plus 2. I substitute it, so it's going to be S minus 40 equals to 2,480. Any questions right there? Let me know. Yes, Margaret. Why I'm plugging to N? Because I know that N represents S minus 40. So I substitute. And the reason I have to substitute into N because we need to narrow it down to just one single variable. We cannot have two variables, right? There. So what do we do here now? Distribute. So it's going to be 2S plus 2S minus 80 equals 2,480. Can I combine anything? What? 4S minus 80 equals to 2,480, and add 80. Okay, so we add 80. I'm sorry. I add 80. Okay, go ahead. Now let me know. Is there anything I should go back? Yes, Ruben. How did I get 80? 2 times negative 40. I distribute. Okay. 4s equals to? Very good. Divide by 4. S is? 640 what? What did we say S to be? Speed, right? So how do you represent speed? Kilometers per hour. So if this is the speed of the southern, what is the speed of the northern? 600. Very good. Any questions there on how we solve this? You good? Okay. I want to let you know something too, that some of you said, hey, maybe we should use elimination here. And you are right. You can. You can always move your variable to make them align, right? Like for example, if you want to force elimination, wouldn't you move the x over to the left to line it up with the s and n line up with n? So you can technically still use elimination if you want to. The reason I'm using substitution is because it's already solved for, so I don't have to do extra work for it. So there it is. This is the problem that I just mentioned. Any questions on this one at all? Okay, very good. So I'm going to go ahead and bring you another problem right now. Remember, I assigned you 2 yesterday. So I'm going to show you this next problem, and I will briefly walk through with you